In this video, I want to talk about antifungal medications. So fungi are eukaryotes, so they're actually pretty similar to us. There are not a lot of differences and therefore treatment is pretty limited. One nice difference that they have within the cell membrane is that fungi carry ergosterol instead of cholesterol, what we have. So actually, ergosterol is the major target of antifungal drugs. And so antifungal drugs either bind to ergosterol or inhibit the synthesis. One very important antifungal medication is Amphotericin B. And amphotericin just binds to ergosterol and therefore disrupts the cell membrane of the fungus, and the fungus dies by lysis. Amphotericin is one of the most broad-spectrum antifungal medications that we have. It's an IV drug, and you're only going to use this in very severe life-threatening fungal infections, because amphotericin will make you feel very terrible, so people also call it sometimes amphoterrible. And it's very renal toxic, so if you're going to infuse it to a patient, you're going to first infuse saline and then infuse amphotericin and then infuse saline again, just to make sure that you flush it out immediately out of your kidney. Another important antifungal medication that targets ergosterol are the so-called azoles, and they target the ergosterol synthesis. So ergosterol is made out of squalene, and then you get lanosterol by squalene epoxidase, and then there's a CYP enzyme, the lanosterol demethylase, which can be blocked by the azoles. And these are things like fluconazole, ketoconazole, voriconazole, so they all end in azole. I also want to mention that the mechanism of action of the azoles tells us something very important, because it blocks a CYP enzyme. That means these drugs have tons of drug interactions because they are CYP inhibitors. That's their mechanism of action. Besides ergosterol, we have one other very important target, and this is the beta-glucan synthase. And this is a little enzyme that sits in the cell membrane that makes this 1,6 sugar connections and forms the beta-glucans, the 1,6 beta-glucans. And this is something very special for the cell membrane of fungi, because we don't have this enzyme complex, we don't have this synthase, and therefore we don't make this beta-glucans, this 1,6 beta-glucans, and therefore this is pretty specific for the fungus. And this drug class that inhibits this beta-glucan synthase are the echinocandins. They all end on fungine, therefore they're also sometimes called the fungines, things like mica fungine. And the last drug that I want to mention is 5-FC, 5-fluorocytosine. And this is actually a prodrug that is converted within the fungi by a fungal deaminase to 5-FU. And 5-FU is an important drug that we even use as a cancer chemotherapeutic agent that will be metabolized 5-F dump, and then you make next the triphosphate 5-FDTP, and then it's going to get incorporated into RNA, and you inhibit RNA and also protein synthesis. You might wonder, why is this specifically happening in a fungus? Shouldn't that also inhibit our own RNA and protein synthesis? Well, the answer here is in the deaminase reaction. It turns out that we don't have such a deaminase. The fungus does have a deaminase, and therefore the 5-FC drug that you're going to administer is a prodrug, and it's metabolized to 5-FU only because the fungus has this deaminase. So this makes it specific to fungal cells. This doesn't exclude that we're not going to see any adverse effects. Well, we could actually see some hematologic toxicities like anemia, thrombocytopenia, leukopenia, because these deaminations can also spontaneously happen. So we can get some RNA protein synthesis inhibition in other cells. The last thing I want to talk about is against which fungi these medications work. And as you know, there's yeast and mold. Yeast is things like Candida and Cryptococci, mold, Aspergillus and Mucorales. I always like to put these azoles into kind of categories. So the older ones, things like voriconazole, they actually only act against Candida and Cryptococci. But then when they developed the later ones, voriconazole, we got already Aspergillus coverage. And then with the newest ones, posaconazole, isovuconazole, we got basically a pretty broad spectrum antifungal medications and cover even mucorales. Now, amphotericin is probably the most broadest spectrum antifungal medications, covers basically everything. And then we have the micafungine. So this is also an important consideration. They inhibit this beta-glucan synthesis. So it makes sense that fungi that do not have a lot of beta-glucan will be not successfully treated with those. And it turns out Cryptococci and mucorales does not have a lot of beta-glucan. So the fungines, things like micafungine, only work against Candida and Aspergillus. And I should also mention there are also IV drugs. The last special indication is Cryptococci infections, where you use normally amphotericin with 5-FC. So 5-FC is actually not used alone. This concludes the video on the different antifungal medication.